This is Dr. Elliot McGucken at 45 Surf University. And I was just going to read a chapter from my book, The Triumph of LTD Theory and Physics over String Theory, the Multiverse, Inflation, Supersymmetry, M Theory, LQG, and Failed Pseudoscience. And basically it's a book about how dx4/dt equals IC unifies quantum mechanics and relativity while also providing a physical model and mechanism for time and all its arrows and asymmetries, as well as the second law of thermodynamics in quantum non-locality, probability, and entanglement, as well as all of relativity. This chapter is titled LTD Theory and Nobel Laureate Physicists versus String Theory / Loop Quantum Gravity. And again, LTD theory stands for Light Time Dimension Theory. And the title of the theory was inspired by the simple equation x4 equals ICT that was found in Minkowski's treatment of Einstein's relativity. And Einstein later credited Minkowski's treatment and the equation x4 equals ICT as a stepping stone which allowed him to develop general relativity. x4 equals ICT provides a firm mathematical foundation for the notion of a fourth dimension that is related to time. So this chapter, Light Time Dimension Theory and Nobel Laureate Physicists versus String Theory / Loop Quantum Gravity, quotes from a lot of the Nobel Laureate physicists on their belief that string theory is not quite physics. The chapter begins. LTD theory was inspired in part by Einstein's words pertaining to the higher purpose of physical theories, noble sentiments which have been exiled by the multimillionaire multiverse maniac. Albert Einstein writes, "Before I enter upon a critique of mechanics as a foundation of physics, something of a broadly general nature will first have to be said concerning the points of view according to which it is possible to criticize physical theories at all. The first point of view is obvious. The theory must not contradict empirical facts." And aside here, right away, string theory contradicts empirical facts because it proposes 9 or 11 or 30 dimensions. It also proposes these tiny little vibrating strings that nobody has ever seen nor observed, and nobody knows how to look for them either. Einstein continues, "The second point of view is not concerned with the relation to the material of observation, but with the premises of the theory itself, with what may briefly but vaguely be characterized as the naturalness or logical simplicity of the premises, of the basic concepts and of the relations between these which are taken as a basis." And again, I need to point out that string theory doesn't really have any foundational principles, nor postulates, nor equations, and it makes no predictions. Einstein continues, "This point of view, an exact formulation of which meets with great difficulties, has played an important role in the selection and evaluation of theories since time immemorial." Albert Einstein. Quoting these words are enough to get one labeled a creationist by the religious multiverse zealots and banned from postmodern physics for life. But being banned from utter and complete failure and snarky nonsense is not such a terrible thing. Contrast LTD theory's elegant unifying success with string theory's not even wrongishness and now entrenched religion of failure. The first page of the book or textbook String Theory in a Nutshell states in a footnoted sentence, "String theory has been the leading candidate for a theory that consistently unifies all the fundamental forces of nature, including gravity. It gained popularity because it provides a theory that is UV finite." And then there's a reference there. There's a little 1 for a footnote. So if we go read footnote 1, it reads, although there is no rigorous proof to all orders that the theory is UV finite. So you see, string theory is not a finite theory, but this is generally kept to the footnotes when mentioned at all. Many Nobel Laureate physicists harbor reservations regarding strings. "We don't know what we are talking about," stated Nobel Laureate David Gross on string theory. While Gross spent a large part of his life promoting string theory, he has since become a bit more skeptical. Though not nearly skeptical enough given string theory's abject and complete failure. Einstein wrote, "It is anomalous to replace the four-dimensional continuum by a five-dimensional one, and then subsequently to tie up artificially one of those five dimensions in order to account for the fact that it does not manifest itself." Well, Einstein's talking about, if you add one dimension and then say, well, you don't see it because it's tied up and too small, that really doesn't make any sense, physical sense, so we're not going to do that. And he tossed that whole approach aside. But, the string theorists came back, and they are now doing that for 13 dimensions, 11 dimensions, 20 dimensions, 30 dimensions. And then they tie them up really small and say, oh, well, we'll never observe them. It's somewhat ironic that string theorists, they rejected all the mechanisms and means by which Einstein advanced science. And that derives from his younger years when he thought in concrete mathematical models. And whenever he invoked a mathematical model, it always reflected a concrete physical model. So at the end of the day, all of Einstein's successes owed to the fact that he thought in physical models. For instance, what it would be like to catch up with a light beam. That led to relativity, and that, he's pondering it in a physical manner. And then in general relativity, he realized, legend has it, he was leaning back on a chair, and all of a sudden, when you cross the point of no return, you start falling backwards. He realized somebody in free fall would not feel their own weight. And that led him to conclude that a gravitational field is the same as an accelerating frame. And he called that the happiest thought of his life, and it led to general relativity. But again, we see there is a very concrete, specific example of a physical feeling, a physical process. So both special and general relativity were rooted very much in that. I mean, you can even look at how quantum theory developed. It was Planck who was searching for a better filament and for light bulbs. And he found, in order to make the math work, he had to introduce the notion of a discrete, indivisible unit of energy. Now, he himself, when he wrote that, E equals HF, he didn't really believe that all energy was quantized. But, it worked out. And it was later on, it was Einstein who looked at that same equation and stated, well, what we see here is energy is quantized. And that was what Einstein actually won his Nobel Prize for, the quantum theory as developed through his photoelectric effect. Einstein, interestingly, never got a Nobel Prize for special nor general relativity. The great physicist, Nobel Laureate Feynman, wrote, "String theorists don't make predictions, they make excuses." The Nobel Laureate physicist Robert Laughlin wrote, "String theory is like a 50-year-old woman wearing too much lipstick." Note how the Nobel Laureate theorists and experimentalists such as Feynman and Laughlin are so quick to dismiss the theory. And another Nobel laureate, Gerard Tooft, weighs in, stating, "Actually, I would not even be prepared to call string theory a theory, rather a model, or not even that, just a hunch. A theory should come together with instructions on how to deal with it, to identify the things one wishes to describe. In our case, the elementary particles, and one should be able to formulate the rules for calculating the properties of these particles, and how to make new predictions. Imagine that I give you a chair while explaining that the legs are still missing and that the seat, back, and armrest will perhaps be delivered soon. Whatever I did give you, can I still call it a chair? and that's Nobel Laureate Gerard 't Hooft. Then another Nobel laureate, Sheldon Glashow, writes, "It is tragic, but now we have the string theorists, thousands of them, that also dream of explaining all the features of nature. They just celebrated the 20th anniversary of superstring theory. When one person spends 30 years, it's a waste. But when thousands waste 20 years in modern day, they celebrate with champagne. I find that curious." Nobel laureate Sheldon Glashow. Now we have third-generation failed string theorists have lived quite handsomely and benefited in a massive manner from groupthink failure, while never even coming up with any ideas of their own, nor even asking any questions of their own. I mean, physics has always been best advanced by the lone individual asking and answering their own questions. Where string theorists, that they fail at answering other people's questions that they never even asked. And I'm not even sure if string theory asks any questions. I'm not sure if it's led by curiosity. Einstein said imagination is more important than knowledge, but if you're doing string theory after 40 years of failure, I'm not sure how imaginative you are. The Nobel laureate Richard Feynman also writes, "I don't like that they're not calculating anything. I don't like that they don't check their ideas. I don't like that for anything that disagrees with an experiment, they cook up an explanation, a fix-up to say, well, it might be true. For example, the theory requires 10 dimensions. Well, maybe there's a way of wrapping up 6 of the dimensions. Yes, that's all possible mathematically, but why not 7? It doesn't produce anything. It has to be excused most of the time. It doesn't look right." Nobel laureate R.P. Feynman. And Sheldon Glashow also writes, and again, he's another Nobel laureate, but superstring physicists have not yet shown that the theory really works. They cannot demonstrate that the standard theory is a logical outcome of string theory. They cannot even be sure that their formalism includes a description of such things as protons and electrons. And they have not yet made even one teeny tiny experimental prediction. Nobel laureate Sheldon Glashow. Glashow continues with, "Worst of all, superstring theory does not follow as a logical consequence of some appealing set of hypotheses about nature." Yes, as we pointed out earlier, unlike Einstein's relativity, string theory has no physical postulates nor principles based on any entity that has ever been physically observed. Einstein, as we remarked earlier in his earlier years, Einstein advanced physics by focusing on experimental results, including the fact that the velocity of light was constant because, that's the way that it had been observed, and also Maxwell's equations, it was embedded in that. An intrinsic part of Maxwell's equations is that the velocity of light is constant for all observers. And then there's the Michelson-Morley experiment, which showed that you couldn't detect an ether drift. Again, that the velocity of light would be the same for all observers. So basically, Einstein advanced physics based on this rock-hard experimental understandings. And again, when he advanced it via looking at Planck's equation, E equals hf, of course E equals hf, that equation was formulated to basically account for the experimentally observed properties of filaments and black-body radiation. So those were both grounded in experiment, very, very, very much so. And Einstein, and of course the photoelectric effect was an experiment in its own right, which Einstein explained via the quantization of energy. So Einstein's earlier years were very much grounded in experimental realities. Now, in his later years, he never really advanced physics at all. I think past the age of 30 or 40, he made less and less, fewer and fewer contributions. And at that point, he kind of said, there's a famous quote of him saying that we can build up all of physical reality from first principles, just mathematical postulates. So he was trying to base all of his advancements of physics on only mathematics, theoretical math, and he never advanced. He never contributed anything after that point. So it's somewhat ironic that the string theorists basically rejected all the mechanisms and means by which Einstein advanced physics, and they adopted the means and mechanisms by which Einstein failed to advance physics. Burton Richter, who was the director emeritus of SLAC, the Stanford Linear Accelerator, wrote, "The anthropic principle, I think, is one of the most stupid ideas ever to infect the scientific community. It is an observation, not an explanation, a theological speculation. They seem to have forgotten they have to be connected to physical reality." And it is indeed amazing how many hours have been taken up contemplating the anthropic principle as opposed to actually performing physics. Burton Richter continues, "To me, some of what passes for the most advanced theory in particle physics these days is not really science. Much of what currently passes as the most advanced theory looks to be more like theological speculation." And Nobel Laureate Laughlin, who got his Nobel Prize in condensed matter, writes, "String theory has no practical utility, however, other than to sustain the myth of the ultimate theory. There is no experimental evidence for the existence of strings in nature, nor does the special mathematics of string theory enable known experimental behavior to be calculated or predicted more easily." That's Dr. Robert Laughlin. Dr. Laughlin points to that as a deceitful turkey, which remains forever just out of reach. String theory guarantees its dishonest, groupthink adherence, endless funding. Yeah, by being a theory that is just always a little bit out of reach, Laughlin calls it the deceitful turkey. So, you get infinite funding, and, tens of thousands of physicists have written tens of thousands of papers, and they're always right on the cusp of actually finding what string theory's equations actually are, because nobody knows what they are these days. String theory has no credibility as a candidate theory of physics. Recognizing failure is a useful part of the scientific strategy. Only when failure is recognized can dead ends be abandoned. And that quote comes from Dan Friedan, and he was an early Rutgers string theorist who I believe he transferred out of pursuing string theory. Dan Friedan once told Lee Smolin that he should immediately begin doing string theory, as in a matter of months it would all be solved and there would be nothing left to do. That was back in the 1980s. And another Nobel laureate, the Martinus Veltman, writes in his book, Facts and Mysteries in Elementary Particle Physics, "This book is about physics, and this implies that theoretical ideas must be supported by experimental facts. Neither supersymmetry nor string theory satisfy this criterion. They are figments of the theoretical mind." And that's Martinus Veltman, Nobel laureate. And Michio Kaku, the famous physicist, wrote a book called Introduction to Superstrings and M-Theory, and he actually writes in his book, "The great irony of string theory, however, is that the theory itself is not unified. For theory that makes the claim of providing a unifying framework for all physical laws, it is the supreme irony that the theory itself appears so disunited." Well, yeah, then why would you devote your life and write a whole book on it? Well, Michio Kaku has written numerous popular science books, and while he jumped upon the stringy bandwagon, it appears that he hasn't ever actually advanced science in any discernible fashion. At least he admits that string theory is an epic mess. And again, we return to Nobel laureate Martinus Veltman, who writes, "If we do away with the experiments, science becomes religion. From that moment on, it won't be the facts that count when we're trying to determine what's true, but the opinions of someone who's been elected pope." That's exactly what we see these days. I think at some point Ed Witten was elected Pope of string theory. And I highly recommend Nobel Laureate Martinus Veltman's wonderful book, Facts and Mysteries in Elementary Particle Physics. And Martinus Veltman notes that string theory is a religion. And again, here's some more thoughts from Nobel Laureate Sheldon Glashow. The theory depends for its existence upon magical coincidences, miraculous cancellations, and relations among seemingly unrelated and possibly undiscovered fields of mathematics. Are these properties reasons to accept the reality of superstrings? Do mathematics and aesthetics supplant and transcend mere experiment? And again, Nobel Laureate Martinus Veltman writes, why is it the only game in town? Just because so many smart people work on it internationally doesn't prove a thing. The majority of researchers are simply hangers-on. Yes, Martinus. Incapable of finding their own way, they simply tag along with Witten and his associates. If I were young today, I would attempt to find a different way from string theory. It is of course a hellish job, but too few young researchers try to do it. And Veltman won a Nobel Prize. It really is quite amazing that string theorists inherit the aplomb and exalted trappings of Einstein while opposing his ruggedly independent spirit every step of the way. Einstein, like all great physicists, was marked by a private, burning curiosity which seems to be totally absent from the group thinking string theorist. Is string theory a futile exercise as physics, as I believe? These are the words of Philip W. Anderson, another Nobel laureate. Is string theory a futile exercise as physics, as I believe it to be? My belief is based on the fact that string theory is the first science in hundreds of years to be pursued in a pre-Baconian fashion, without any adequate experimental guidance. That's Philip W. Anderson, physicist and Nobel laureate, Princeton University. I studied with Anderson while attending Princeton, and like his colleagues Wheeler and Taylor, and Feynman, who had studied with Wheeler, he doubted the merits of string theory alongside his fellow Nobel laureates. And Laughlin, the Nobel laureate, remarks that if Einstein were alive today, he would be horrified at this state of affairs. He would upbraid the profession for allowing this mess to develop and fly into a blind rage over the transformation of his beautiful creations into ideologies and the resulting proliferation of logical inconsistencies. Einstein was characterized by never arguing with experiment, demanding total logical consistency, and mistrusting unsubstantiated beliefs. Yes, so there you have it. Many of the world's leading physicists, including honorable Nobel laureates, do not believe that string theory is actually science. And yet, Brian Greene and his friends continue to completely ignore and downplay these giants, while continuing to get all the TV time and book deals and conferences and interviews on Joe Rogan. Such is the nature of our fallen era of physics. But there is hope. And two, there are yet more scientific luminaries and Nobel laureates who question the scientific integrity of string theory, whom we celebrate in the following chapter. Well, I hope you enjoyed that. That's a chapter from my book, The Triumph of LTD Theory and Physics over String Theory, the Multiverse, Inflation, Supersymmetry, M-Theory, LQG, and Failed Pseudoscience. dx4/dt is equal to IC. This is Dr. Elliot McGucken at 45 Surf University, where we celebrate the foundational principle that the fourth dimension is expanding at the velocity of light relative to the three spatial dimensions.